All right, we're going to go straight into section 7, which is graphs of rational functions. In section 6, we talked about how to find horizontal and vertical asymptotes. Now we're going to take that and add it with everything else that we know. So, some guidelines for graphing rational functions. Remember, p of x is standing for the numerator, q of x is standing for the denominator. We want to simplify it if possible. Any restrictions on the domain of f not in the simplified function should be listed. So if I can cancel a factor from the numerator and denominator, I still need to note that that denominator needs to be a whole in the graph. So like, if my function is x plus 3 times x minus 1 over x minus 4 times x minus 1, we talked about how we can cancel these out, right? Gives me x plus 3 over x plus 4. But it's very important to remember that x still cannot equal 1. That's going to give you a little hole in the graph. We won't see many of those, but just know x still can't be 1. Find and plot the y-intercept by evaluating f of 0. Find the zeros in the numerator, if any, by setting the numerator equal to 0. Then plot the corresponding x-intercepts. Find and sketch all vertical asymptotes. Find and sketch any other asymptotes. Plot a few more points to get the basic shape and connect them using smooth curves. So there's another type of asymptote called a slant asymptote. If the degree of the numerator is exactly 1, more than the degree of the denominator, there's a slant asymptote. If it's 2 greater, then it doesn't have a slant asymptote. So that's like if I said y equals 3x cubed minus 5x, whatever, over 2x squared plus, I don't know. The numerator has a degree that's exactly 1 greater. There will be a slant asymptote. To get the slant asymptote, we simply divide the denominator into the numerator. The quotient is the equation, and the remainder is the value of the function as x approaches infinity. We won't worry about the remainder. But so to find the slant asymptote here, I would take 3x cubed plus 0x squared minus 5x plus 0 divided by 2x squared plus 0x plus 7. Oops. So this is not going to be a nice one because I made a terrible choice, but this is actually 3 halves x. So I have 3x cubed plus 0x squared plus 21 over 2x. I'll give you nicer numbers here, but we subtract and I get negative 31 over 2x plus 0. I can't do anything else. The equation of the slant asymptote is y equals 3 halves x. Usually I'll give you better numbers. Don't worry. So we are going to find everything I need about this one and graph it. One little mnemonic device that some people like is to remember that Dr. C is a B. And that just reminds you everything you need to find. D is for domain. R is for range. C is for continuity. I is for intercepts. S is actually for symmetry. Most of our graphs don't have symmetry, so we usually skip it. A is for asymptotes. B is actually boundedness. So basically, is it restricted above or below it all? And E, well, the first E, is for extrema. That's your maxes and mins. And the other E is end behavior. If we figure all of those things out, we have a pretty darn good graph and all the information we need about it. So let us begin. First thing we want to do, the domain. Well, the domain is anything that can be plugged in. We cannot set the denominator equal to 0, so our x value actually cannot equal -1. So our domain is everything but -1, so it's -infinity to -1, or -1 to infinity. Our range. The range is the trickier one, and we're actually going to hold off on the range. I don't do these in order. So, continuity. It'll be continuous everywhere except -1. So, discontinuous. X equals -1. I-intercepts. For the x-intercepts, we set the function equal to 0. So if I set 0 equals x squared minus x over x plus 1. Well, if I multiply x plus 1 over, look at that, 0 equals x squared minus x. All right, we basically just set the numerator equal to 0. We factor it, I get x times x minus 1, so I get x equals 0 and x equals 1. So my x-intercepts are 0, 0, and 1, 0. My y-intercept, if I plug in 0 for x, I get 0 minus 0, which is 0, over 1, which is 0. We already said that one, 0, 0. Symmetry. Symmetry is if it's like even or odd. This function is neither of those. There's no symmetry. Usually there won't be, and I probably won't even make you write it. A is for asymptotes. So vertical asymptotes, x equals -1. Horizontal asymptotes. Well, the numerator's degree is bigger than the denominator, so there's not a horizontal. The numerator is exactly 1 larger than the denominator, though, so there's a slant. For a slant asymptote, we take the numerator divided by the denominator, and I get x minus 2x plus 0 minus 2. And it doesn't matter, we don't care about the remainder. Y equals x minus 2. Oops, x minus 2. That is my slant asymptote. I'm going to leave a little space there because there's something else we're going to have to write. B, boundedness. That's something we'll talk about in a moment. E, extrema. We'll also get there. E, end behavior. Also get there, but remember that is the limit as x approaches -infinity and the limit as x approaches positive infinity. All right, let's start looking at the graph. Graph everything we know about it so far. I know that I have an asymptote at -1 and an asymptote of x minus 2. That means -2 and a slope of 1. This is my sketch. That is my horizontal or my slant asymptote. All right, I got my asymptotes. I want to graph my intercepts next. 0, 0 and 1, 0. Okay. Now I'm kind of set, right? I need to start picking a few points to plot. So let's say I pick x is -3. Plug -3 into my function. I get 12 over -2. I get -6. It's about here. How about 3? 3/4. About there. So this tells me a bit about what my function does. I'm pretty sure at this point, because my function will approach this slanted line, it's going to go like that. And from this point, it'll go like that. It can't cross the vertical line, so that means it's probably going to go like that. The other parts are the weird parts. And this is where your graphing calculator is totally okay to use. Make sure you put parentheses around the numerator, x squared minus x, and parentheses around the denominator. All right, I was wrong about my function, wasn't I? I plotted something somewhere wrong. All right, ignore the purple graph then. My graph actually goes like this. A little there. There we go. All right, I did my math wrong somewhere in here. My bad. Okay. So now we can answer a lot more about this. The limit as x approaches negative infinity. As I go far left, my graph is going down forever. That's negative infinity. As x approaches positive infinity, it's going up forever. That is positive infinity. Let's look at our range. Our range, there's a little gap in here. So it's not all real numbers. To find that gap, we need to find these lowest and highest points. Those are our extrema. And we can use a calculator to find these. Second, calculate minimum. Well, I have a little minimum right there, so I want to get on the left-hand side, press enter. Right-hand side, press enter. Guess, press enter. That's not a nice number, but we have a minimum, relative minimum, at 0.414, negative 0.172. And then we have a relative maximum that I will calculate also. This time choose number 4. I have to push the over arrow until I jump down to this other piece of the graph. Get on the left side. Get on the right side. Guess. Again, not nice numbers, but we have a relative max at negative 2.414, negative 5.829, sorry, 8. Okay, so that means the gap here is from negative 5.828 to negative 0.172. So the range is everything below negative 5.828, but it includes it, so bracket. Or we pick up again at negative 0.1, bracket negative 0.172 to infinity. That's a weird one. All right, boundedness. This one, since it goes up and down forever, it's kind of bounded in the middle, bounded like there's a boundary. We're mostly going to skip boundedness, but it goes on forever, so we say unbounded. And then there's one more thing we have to add for the asymptotes. Any vertical asymptote needs you to talk about the behavior at that asymptote. So x equals negative 1. We need the limit as x approaches negative 1, but notice it goes different directions. We put a little minus, meaning as I approach negative 1 from the left side. Well, from the left, that piece of the graph goes down forever, so that is negative infinity. Then we also need the limit as x approaches negative 1 with a little plus. That means from the right side. So as I come in from the right side, it goes up forever. That's positive infinity. So realize these are just talking about those two different parts of the graph. All right, let's try this one. This just says find the asymptotes. Cool. Vertical asymptotes. Set the denominator equal to 0. X equals positive 1 is my vertical asymptote. Boom. Horizontal asymptote. The degree of the numerator is bigger than the degree of the denominator. There is no horizontal asymptote. Slant asymptote. The degree of the numerator is exactly 1 bigger, so we divide. X squared minus x minus 2 divided by x minus 1. I get x and a 0, so the slant asymptote is y equals x. And there's all of our asymptotes. All right. All right, we're going to do everything for this one. I actually like to start with my asymptotes, so let's do that. Set the denominator equal to 0 for vertical asymptotes. So I'm going to factor it, 2x and x, 3 and 1, minus 3 plus 1. So x equals 3 over 2 and negative 1. It's my asymptotes. All right. Horizontal asymptotes. The degree of the denominator is bigger, which means y equals 0 is a horizontal asymptote. If there's a horizontal asymptote, there will not be a slant. All right. The domain follows very quickly from here. Domain. Everything but these x values that it can't be. So negative infinity to negative 1, or negative 1 to 3 halves, or 3 halves to infinity. The range we will look at in a little bit. Continuity, it is discontinuous. At x equals negative 1 and x equals 3 halves. And as just a warning here, remember it's Dr. C is B. Going through and checking those things off in my head. So we have talked about the domain. We have talked about the continuity. We have talked about the asymptotes. All right. Intercepts. Intercepts. For x-intercepts, we set the numerator equal to 0. Well, that's simply not true. There are no x-intercepts. For y-intercepts, we plug in 0 for x. That gives me 2 over negative 3. That's negative 2/3. All right, finished my intercepts. Symmetry, again, it's almost always going to not be symmetric. Boundedness, don't worry too much about it. We'll look at the graph. E for extrema, E for end behavior. We don't know exactly yet, so let's look at the graph. What I know about my graph right away is that x equals 3 halves is an asymptote. So let's see, 1, 2, that's right here in the middle. X equals negative 1 is an asymptote. And y equals 0. Okay, that's hard to see, but okay. My domain is all those. No x-intercepts, but I have a y-intercept at 0, negative 2/3. All right. Now we don't really know what this graph looks like. So let's pick a couple numbers. Let's pick something to the left, the left of negative 1. Let's try negative 2. 2 over 2 times negative 2 squared minus negative 2 minus 3, 0.28. So my graph goes to the point negative 2, positive 0.28. Like right there. Okay, to be sure, let's try negative 1.5. Second entry, so I don't have to retype the whole thing. 1, click insert, 0.5. 1, click insert, 0.5. 0.66666. That's higher. All right, that right there tells me this graph is most likely going like that. Then let's pick something between negative 1 and 0. Let's go negative 0.5. This one's easy. I will just delete these ones. I get negative 1. Negative 0.5, negative 1. That's lower than what it was. Okay. Let's try positive 1. Actually, let's just try positive 0.5 because then I don't have to change anything but this negative. Negative 0.666. Let's see here. That's the same as my y-intercept. Okay. Let's try negative 1. Oops. Or sorry, positive 1. I get negative 1. I'm going back down. So it looks to me like I'm going to have, nope, I'm an idiot. Wait, no, never mind. There we go. And then let's try plugging into, I keep pushing that. I get positive 0.66, and usually it might look something like that. All right, we'll check our graph before I do anything else. So make sure I put the numerator in parentheses and the denominator. And look at that, that's kind of what my graph looks like. So, range. The range does have a small gap in here. Obviously to 0, right? Negative infinity to something. We can't actually hit 0 up to infinity. It's not this point here. It's not the y-intercept because it went up and back down there, but it's very hard to see. So, second, calculate, maximum, left side, right side, enter, 0.2499, negative 0.64. So that little maximum there is negative 0.64, but it's at, x is 0.25. And we'll put a bracket there because x can be exactly that. Oh, sorry, we're talking range. That's the y value, negative 0.64. Sorry, there we go. Also, our extrema. We only have that relative max at 0.25, negative 0.64. These other ones don't count as mins because they get closer and closer and closer and closer. All right, so we have done our range, extrema. We need end behavior and behavior at asymptotes still. So, end behavior. The limit as x approaches negative infinity. The far left side gets really, really close to 0. This is the first time our limit has equaled a number instead of infinity or negative infinity. That is the value of our asymptote, our horizontal asymptote. And the limit as x approaches positive infinity, well, we get closer and closer to y equals 0 again, so that one is also 0. And then at our asymptotes. For the asymptotes, remember we need to go 3/2 from the left. So our first asymptote coming in from the left, we go up, so that's infinity. But we also need to go from the right. So that's the little plus or minus there. And that means we're talking about this section because it's the closest one on the left. It's going down, so negative infinity. And same thing, the limit as x approaches negative 1 from the left. Well, negative 1 is here coming in from the left. That side is going down, so it's negative infinity. And as I approach negative 1 from the right, that's going up over there, so positive infinity. And there's everything about our functions. And one more for us today. Friendly reminder, we want to find Dr. C is a B, but also remember we probably don't have to worry about S and B. All right. First step, let's set the denominator equal to 0. So 2x equals 1, x equals 1/2. So I know my domain is negative infinity to 1/2 or 1/2 to infinity. I also can start in on my asymptotes. There's an asymptote at x equals 1/2. I know that I will have to find the limit as I approach that from the left and the limit as I approach it from the right. We'll come back to those. Horizontal asymptotes. The numerator is bigger than the denominator, so there's no horizontal asymptote. The numerator's degree is 2 bigger than the denominator's degree, so there's no slant asymptote either. All right, we got domain and asymptote. Continuity. Discontinuous at x equals a half, and that is our only spot of discontinuity. Intercepts. Our x-intercepts, we set the numerator equal to 0. 3x cubed minus 2x squared plus x minus 1 equals 0. I can't factor that. I could try synthetically dividing by 1 or 1/3, or I could take the numerator, 3x to the third minus 2x squared plus x minus 1, and I could graph it. And I could calculate that little intercept right there. Second, calculate 0, left side, right side, enter. Oh, look at that. It's at 0.784. Gross. All right. 0.784. Y-intercept is easier. Plug in 0 for x's. I have -1 over -1. It's +1. All right. Intercepts. Extrema and end behavior. We got to go to the graph for those. All right. Asymptotes, we only have a vertical asymptote at 1/2. We have an x-intercept at 0.7, which is like here. Y-intercept is 0, 1. Wonderful. I don't know what's going to happen. So I start picking some numbers to plug into my function. Let's say I plug in 1. Let's plug in 1. All right, bunch of parentheses. 3 times 1 to the third power minus 2 times 1 squared plus 1 minus 1 over 2 times 1 minus 1. I got 1. Okay. So 1, 1 is a point. Let's try 2. Second entry, change all those to 2's. I put those 1's in parentheses just so I could remember that's exactly where I'd have to change them in a minute. 5.6. So that's getting higher. All right, my guess then is that this graph is going to go like this. And over here, let's try -1. So I'll change all those 2's to -1's. Oops. $2.3. There's 1, so it's up here. All right, this piece looks like it's gonna go like that. Let's check the graph just to be sure. Parentheses around the numerator. You know, and I just cleared it out. I could have just put parentheses around it and then added the denominator, but oh well. Okay. I was wrong. That is not what my graph looks like. I had this side kind of right, but this side I was very, very wrong on because I didn't check anything in between here. So that happens. That's why we check the graph. Start a new graph, right? 1/2, 0, 1, 0.67. This piece looks kind of more like a weird squiggle, but you know, it is. This piece actually goes up from where I had it. All right, now we can find the rest of our stuff. The range. This piece goes negative to positive infinity, so our range is negative to positive infinity. All right, what else have we not found? Our behavior at the asymptotes and end behavior and extrema. All right, behavior at the asymptote. Coming in from the left, it goes up. Oops, sorry. Coming in from the left, it goes up, so that's positive infinity. Coming in from the right, it goes down, so that's negative infinity. All right. End behavior. I like end behavior next. the limit as x approaches negative infinity is, the far left goes up forever, so it's infinity. And the limit as x approaches positive infinity of our function, the far right also goes up. There we go. And extrema. I have a relative minimum right here. I am going to calculate that. Calculate minimum. That is negative 0.157, whatever. All right. Relative min at, my calculator says negative 0.158, comma 0.927. And then we have figured out everything for our graph. So you have to sketch the graph. You have to find the asymptotes. You have to find the domain, asymptotes, continuity, and intercepts by hand for sure. The limit at the asymptotes, the range, extrema, and end behavior. You can look at the graph to be sure you're drawing it right, and then determine them from there.